I'm Anil Kumar, and here is a thinking question on quadratic functions. The question is, a new playing field is surrounded by an oval running track. Two laps around the track are to be 1000 meters, and the rectangular infield area is to be as large as possible. What is the length of the infield which maximizes the area of the infield? That's the question for you. I've seen this paper in many test papers, and it's kind of a difficult question to solve. This is how we can solve it. Let's first sketch, right? So we want this rectangular infield to have maximum area. That's kind of critical, and it has a track all around, and so it looks oval. So that is how the field is, correct? So what we want here is that the tracks are 1000 meters, 2 laps, right? So 2 laps equals to 1000 meters. That means 1 lap is equals to half of it, 500 meters. So that is the perimeter, correct? So that is the perimeter which we have. Now let's say the infield length is, let us say L, right? So this will be L, this will be L, and let's say this here is R, the radius of semicircles which are formed on both the sides. Let's say these are R, right? Now in that case, what is the perimeter? So we know the perimeter, which is 500 meters, is sum of length plus the circumference, correct? So the perimeter, that means all this around the field should be L plus L, which is 2L, plus 2 pi r. That becomes half circle, that is another half circle, so one full circle, right? So that is 2 pi r. 2 pi r is the circumference of this circle with radius of capital R in our case, right? Now 500 is 1 lap. So we can write this as 500 equals to 2L plus 2 pi r, correct? Now we can divide by 2 to get 250 equals to L plus pi r. Now from this equation, we can actually write what L is in terms of R, right? So we can say 250 minus pi r is equal to L. So I'll call this as our equation number 1. So that is the relation between the length and R, the radius of the circular part on the ends, right? So we have a relation between the radius and L. Now let's read the question once again. It says, a new playing field is surrounded by an oval running track. 2 laps around the track are to be 1000 meters, and the rectangular infield area is to be as large as possible. So that is to say, we want to make, or we want to maximize this area. So this is the infield area which we want to maximize. Do you understand? So this area we want to maximize. So what is the area which we want to maximize? Let's write down the equation for that. The area which we want to maximize is this rectangular area, whose one side is L, the other side is 2R, right? So this is 2 times R. From here to here, R plus R, 2R, right? So the area is L times 2R. Now we know what L is. L is 250 minus pi r. So we'll substitute that here. We have 250 minus pi r, and we'll multiply that by 2R. So that is the area for the infield, right? So we got area of infield, so infield area. Okay. If I open the brackets, what do I get? I get 250 times 2, which is 500, r minus 2 pi r square. Now this is a quadratic equation, right? Let me rewrite this as minus 2 pi r square plus 500r, right? So that is the quadratic equation. Now this quadratic equation in R suggests that it will be a parabola, kind of like this. Is it okay? Like this. So the vertex of this parabola will give us the maximum area, right? So let's find the vertex of this parabola. So to find the vertex, what we can do is we can adopt either factoring, find the center point, or we can do completing the squares. So either way you can get the vertex. So what I will do here is we'll factor and then find the axis of symmetry. So I'm adopting that method, okay? So when we factor this, I mean coming back to the same kind of equation, okay? So 2 is common and r is common. In fact, we'll use the same equation, right? So we are coming back to this equation. Once we factor, we get the same equation, which is, let me write minus 2 r as common factor. In that case, we get pi r. Dividing by 2, we get minus 250, right? So we kind of interchange this position. That really means that this parabola will have two intercepts, right? These two intercepts are at r equals to 0 and at r equals to, this point will be 250 divided by pi. Is it okay? So these are the two zeros where this axis is in terms of r, right? And here we have the area. Okay, so this becomes the area. It's important to visualize what we are doing, correct? Now, the vertex will lie right at the center. That is how you find the maximum point when the quadratic equation is given in factored form. So the center point will be average of these two. So we can add them up, divide by 2. So we get this as 250 over 2 pi, which is same as 125 over pi. Is it okay? So that is how we get the value of r, correct? So that is how we get the value of r. Okay, so what we did here was that we found the intercepts or zeros, right? So we have zeros at r equals to 0 and at r equals to when pi r equals to 250, which is when r equals to 250 divided by pi, correct? Then we calculated the axis of symmetry, right? So axis of symmetry will be midway. That means 0 plus 250 divided by pi, everything divided by 2, and that gave us 250 divided by 2 pi or 125 over pi. So we got r, right? So width is 2 times r. Now we know what L is. So we can substitute this value. So we have r, the value to maximize area. So for maximum area, r is equals to 125 divided by pi. Now we need to find L, so we can substitute in equation 1. So L will be equals to 250 minus pi times 125 over pi, correct? So here pi and pi cancels, so you're left with 250 minus 125, which is 125. Is it okay? And so we got length of 125, right? Since the units are in meters, we'll add that units, meters, okay? So the dimensions will be that the radius is 125 by pi meters and the length is 125 meters. In a way, so we have this length as 125 meters and this width from here to here, this width will actually be twice this, right? Since radius is 125, so that'll be 250 over pi. So r is 125 over pi, right? I hope that gives you a good concept of solving such questions. I'd like you to go through this. Important thing here is we are only considering area of the infield. If you actually write area of infield plus the circle, then you'll get a different result altogether, since circle will form the maximum area for given perimeter. So that's kind of important to understand. We are actually concentrating on infield, and that makes this question very typical. I'm Anil Kumar. You can subscribe and share my videos to learn a lot. Thank you and all the best.